Okay, we should be live here. Let me make sure. Yeah, our filters are good. So, happy Monday. Let me switch this over. So today, we're gonna finish something I started late on Friday. Um, the code was like in a crazy mid spot, but what we're doing here, I have a few different contributors that have made Python environments at this point. I'll show one of these that I've ported so far. You can check this on puffer.gg. So we had a contributor who made this Pong game, really hard, um, and it was submitted in Python, and I ported it to native C so that we could compile for WebAssembly. There's no real performance reason to do this, but it is very nice to be able to have like a standalone in WebAssembly so that you can do this with it. So what we're gonna do is we're gonna finish porting breakout to this. We're gonna put breakout online, and then the thing that I want to also get done this week, which is gonna be a little bit harder. Right now, there is this very obnoxious pain point in that you have to, in order to go. Oops, I realize I don't have the chat up on screen either. Let me fix that. Hey, Linky. But I realized that in order to go from Python to Python to C, it's a little bit tricky. And there tends to be a lot of boilerplate associated with that. So I'm going to look for places that we can reduce and eliminate boilerplate so that we can just have a lot of nice clean C files. The one other thing I have not figured out yet is whether I want each environment to be a pure single file C standalone, or if I want to share some render and utility tools. I kind of like the idea of having each environment be self-contained because, like, in my head, like, yeah, there are probably some common utilities that I could factor out, and then it's kind of cool, right? Because, like, oh, yeah, you can use PufferLib for this stuff. But I think that the correct design decision is probably going to be to make these completely or almost entirely independent. The one thing that we will reuse are the custom, the neural net architecture code, because that's a little tricky to redo every time in C. But yeah, we're going to start with this today, and we'll see where this goes. Uh, where are we? Breakout. Okay, so here's our breakout stuff. This is what I had started on yesterday or Friday. This is like a very quick hacky port of the game. And I'm pretty sure that this just seg faults. So let's go fix that. Right, so there was like a whole bunch of stuff that I guess I just didn't port correctly. Breakout.c. Yeah, so I remember now. There was like this really obnoxious thing where the signatures are gigantic. This is one of the things that we're going to have to fix. But essentially, this is an artifact of having to have bindings for Python, Python, and C, is you get these really obnoxious call signatures. This is one of the things we're going to end up having to figure out how to fix. But for now, I think all I have to do is... Probably need to go pull up the Python code for this. Yeah, so here's Noah's original code. Noah's a contributor to Puffer. So when this is done, we're going to put, on this in Pong, we're going to put attribution to the original, the devs of the Python versions. You know, it'll be like code by so-and-so, port by me. Yeah, you can see this ridiculous signature, right? They're like a wrap. Yeah, we'll side by side it. Because basically we just need this to have the same signature. Yeah, look at that. So, I don't know why the order is wrong, so we're going to do float dt, frame skip, and then the allocate function, you can skip all the numpy stuff. The design of this is such that, so you have an init function and an allocate function, and they are different. And the reason for that is that the allocate function has to construct all these buffers. But when you create a breakout game from Python, you actually do all the memory allocations in Python, and you pass that memory into C as a buffer. And the reason for that is that means you have shared memory across Python and C, and then if you do that, then you can get transparent access to all the state data of the game in Python and in C. So you get this nice mirrored effect. That said, I don't think that this is the way to do it. This is just like way too much stuff to pass. This probably should be like one big contiguous struct or something, but we will figure that out later. Welcome, YouTube folks. Okay, so rewards, scores, episodic returns. The first thing here that we need is paddlewidth, hit counters, num agents. Where did num substeps come from? That's awkward. Yeah, I don't know what this is, but we don't need this. Oh, hey, Noah. Welcome. I'm porting your stuff. Yeah, I don't know if you're around here, but I'm going to show you exactly how I'm going to manage all this stuff today, and I'm going to come up with some cool ways to improve on this. Because actually, this is not just a you problem. I've had this problem with my stuff as well, and I think we're going to do some cool design to get around this today. But yeah, you're going to have your breakout game online and playable on PufferGG today, so that's probably pretty cool, right? And like I told you not to worry about it because, like I said, I told you I would like just do this stuff and help fix stuff on stream, and that's what I'm doing. Promise kept. For other folks watching, if you submit environment code, like if you're gonna submit like some of the other Atari games or like other environments, I will do this with you as well, and you'll get to see how this type of stuff works. Can't stay very long as I have work. And no worries, the VOD will be up if you want to see this stuff later, and so will the final code. But absolutely, thank you for the environment here. It's going to be really cool to have ultra fast breakout online. Okay, that's a good signature. Just have to adjust this. I also think that the vectorization, while like internal vectorization was a cool idea initially, I think it only makes sense for environments that are actually natively multi-agent. I think what we're gonna do is we're gonna have each environment only have the one agent, but then we're gonna parallelize in C. So we'll have like we'll have a way to allocate like the array of environments in C so that you can do the step vectorized operation. but you don't have to have the logic of the env itself have that extra dimension, because that extra dimension is pretty gross. Really doesn't do anything for cache coherency. Really doesn't help you with very much. I could be wrong about that, we'll see. It doesn't degrade performance. I think it'll only degrade performance if you put that whole loop in Python. I think that if you just have like the loop over environments in C, you should be fine. Oh yeah, the other big idea I had lately that I just talked with somebody who would really like it if we had this. I don't want to commit to this just yet, but I'm thinking that I might do a custom memory allocator for all the environments in PufferLib, where it just gives you a big blob of memory, right? And then it takes the memory segments that it needs for each individual piece of data out of that. Because what that would let you do is it would let you do really fast state reset and set operations, which would allow you to do like MCTS and stuff incredibly quickly, because essentially set state is just mem copy at that point. That was the other idea I had recently. Well, to be fair, I've had that one for a while, but you know, I just thought about it. I just started considering it seriously just now based on a meeting I had. Okay, so 63. Assuming here init C breakout actions. I think this is actions is unsigned char star. Recently, the Raylib dev Rayson said that he wished that C didn't have signed versus unsigned types. Just everything was signed, and maybe we have an extra type for bytes. I thought about it, and he's totally right. Okay, so why does this not exist? There should be num balls. Ah. Crazy function signature. We'll get this right now, and then we'll simplify it. So this is actions, observations, rewards, scores, episode returns. We don't have numballs here. I think this is int star. Number of balls. Then we get paddle positions, ball positions, ball velocities, brick positions, brick states, guns, and then we get int star balls fired. So wall positions. Yeah, so I guess the signature just got messed up somehow when I ported. Wall positions, then we do paddle widths, paddle heights, ball speeds is not here. Ball speeds, hit counters, agents, width, height, ball width, ball height, brick width, brick height, ob size, no bricks. Yeah, there you go. So that's the whole signature. Get rid of this def. Paddle heights. I guess, did I miss one here? Are there actually any industry jobs in reinforcement learning? Of course. Yes. Like, also, being in any area of ML, you can be in any other area of ML in like a month. Like if I wanted to be working on, transformers, on that side of things, it would literally take me a month to catch up with all of the latest literature from the past several years and to just be doing that. It's like the exact same set of skills. But yeah, there's like a lot of stuff in robotics. There's some random stuff in industry as well. Like there's some like random stuff in like optimization of layouts and whatnot. It's not like nobody does RL. I mean, like if you think about it, right? Like you're not solving every problem with a 400 billion parameter model that you can only access via an API that only knows about language and can't like adapt quickly to new, not unintuitive problems, right? That's what RL is for. I don't know how I missed this one. Duplicate member. Did I not pass width and height somehow? I could have sworn I did. Oh, right here. It's missing. Ridiculously long function signatures. And then, okay, so right here I just have to call this correctly. So we have DT, frame skip, actions, observations, right? Yeah, that exists. Rewards. Scores. I'm just checking to make sure each of these exists. Balls. Did we not allocate number of balls? Yeah, we didn't allocate number of balls here. Episodic returns. Int star, numballs. Paddle positions. All positions. All velocities. States. Duns has to go. Let's start Duns. Also missing balls fired. And then paddle widths. Paddle heights. Ball speeds. hit counters, and then num agents gets passed in. This is correct. Width, height, ball width, ball height. Brick width and brick height. Mob size. No bricks. Brick rows, no brick calls. Didn't you define done twice? Dones? Looks like you are correct. Apparently this is unsigned char as well. Good catch. Yeah, this function signature is way too long to keep track of. Basically, like, half of this stuff is gonna end up getting packed into a, like a game state struct or something. Okay. Balls fired. Should be int star. Oops, this is int. And actions is supposed to be unsigned char. Direction. Float. And then these are just defined in the wrong order. Usually what we do here is, because this is one pass compiler, I put reset and step at the bottom, and that normally just handles everything. Well, I don't put it at all the way at the bottom. I put it at the bottom of the logic, which is right here. Is pi not a built-in? m_pi. Okay, now we have legitimate bugs in the port to fix. Float and int. Hit counters. I assume this is supposed to be an int, right? Star hit counters. Oh, we double assigned. That doesn't matter, but it's weird. Okay. That jumps us down to here. Subscripted value. Rec positions. I think this is a 2D array, right? Apparently brick positions is a 2D array. Where does this get set? Brick. This might get set from Python in the original code, right? Brick positions, because I don't see where this is getting set. Like, where are they populating this? Nowhere, right? It would be in reset if it would be anywhere, and it's not here. So I'm assuming what this is happening is that this is using the Python logic. Step. I don't see it in here, though. Oh, wait, here it is. Right here. Populate it once in Python. Yep, I see it. Cool. Put this in C. And then where should we put this? I guess we'll make a function somewhere. It's probably got to be up here. Oops. This. And then we just do void generate brick positions C breakout star env. Oops. Positions, and then this gets allocated to zeros, right? And I think that this now has to be brick positions. Yeah, but num bricks is this variable. This is kind of awkward. It's very awkward, actually. I think the easiest way... Well... It depends if I want to have this be like a weird breakout variant where you can have like different breakout games or whatever. Probably I shouldn't be caring about that at the moment. So it's just kind of gross because like with the number of bricks not being a constant, I can do it like this. Yeah. I generally don't do 2D arrays for position. Are you purposely avoiding something like vectors? Yes. Yes, I am. We just use simple arrays. We're also writing C, not C++. This is ultra high performance sim, right? We don't need dynamic length. We don't need all these things. The goal is not just to implement breakout, right? That's easy. The goal is to implement stupidly high-performing breakout for reinforcement learning. All the sims have to run a bare minimum of a million steps per second, at the very least. We'll just do X. Continuous memory. Yeah, in fact, I want it to be more continuous than it already is. I think eventually the way we're going to go is we're going to have a custom mem allocator that just gives you one giant block of memory for your entire sim state so that you can very easily set and like reset states, which would then allow you to do like MCTS and stuff. It'd be nice. It's actually very funny to me that like I've seen some very bizarre functional stuff like for trying to do this, like just functional state stuff. Like you don't need any of that. You just need contiguous allocated memory. And then you can be way faster because functional code is very slow. Memory arena. Yeah. When running a sweep... Oh, I just realized this is not visible over my camera. There we go. When running a sweep, can it happen that the solution of hyperparameters overfits to the set seed, but doesn't perform well for other seeds. Yes, I'm aware of that. That is a limitation of WandB, not of of my approach. So WandB doesn't make it, as far as I can tell, WandB does not make it easy to run multiple seeds and collect data across them. So the way that I do it with WandB sweeps, I don't actually save the model from the best run. So you end up having to retrain anyways, and it's not fully deterministic. So you basically end up having to re-verify that these hyperparameters actually work anyways. And in practice, the hyperparameters, they almost always reproduce the result. However, there is a little bit of a difference. Like, you have to actually look at the curve. Because what happens is many times you'll get approximately the same curve, but it'll collapse at some point, and the point at which it collapses can shift a little bit. That's the largest variance that we get. If I may repeat a question I asked on Discord, if I missed a question on Discord, my bad. In your opinion, is carbs that much more compute efficient that it is worth dealing with the growing pains it may still have versus just using Optuna? I don't think anybody has good Optuna integrations with RL either, unless I'm mistaken. I guess actually CleanRL kind of does, right? CleanRL does a thing with Optuna. It depends what algorithms you're using from Optuna. Carb seems really, really nice because it's like this really fancy Gaussian process based thing that maintains a set of Pareto optimal points and is compute aware, so it looks for longer solutions as it becomes more confident in its predictions over shorter solutions. So it's pretty interesting. As for whether the growing pains are worth that, that's up to you, but I'm the one currently dealing with the growing pains, right? Like, I deal with that by integrating with Puffer. So if stuff doesn't work, you just let me know and I fix it in Puffer, right? No, brick positions are X and Y, right? You did like X comma Y? Is what it looks like. I'm pretty sure. Perfect. Why would... Why? I'm not gonna Alta 4. Roll. Oops, this brick Y. Yeah, next you're gonna ask me if I can code up some Ligma. Oops. I gotta pay attention. Almost messed up the indices. Brick positions. Ah, right, we didn't finish porting this yet. So this is already allocated. Y offset. Oops. R. Sure, we can do row and call like this. And we have index. Do you use IDX here? You do use IDX. Call times brick width, row, brick height, Y offset. This is good. The only thing I want to change is I want to do this. And there we go. And now when you init breakout, you should do generate brick positions. This is M pi F handle brick wall. Oh, because this I was for agents, right? You don't need this I anymore. Wait, no, this is frame skip. Did I mess up here? I don't think so. Hold on. Brick. Oops. Oh, it is agent IDX, so we don't care about this. We can just fix these function signatures. I forgot semicolons here. Click IDX. Wait, is this correct? It's changing the loop variable in the loop. This doesn't look right. Where the heck did this line come from? I think I can just delete this line. I don't know where that came from. Paddle width. Do we need paddle width here, right? No, I think it was fine. I think that you did it correct. And I probably like tabbed a dumb super maven suggestion. Don't use LLMs, kids. Say no to LLMs. I swear, even like the very small amount that I use them for like saving typing, occasionally I screw up and like tab too quickly. Definition of height. Yeah, we're totally gonna make like some struct-based state thing for this because this is ridiculous, all these variables. Okay, which of these variables are correct? Let's figure this out. Breakout pi. 576. These ones are correct, right? So, paddle width. Paddle width. Yeah, it looks like these ones are correct. So we get rid of this, this. Paddle. Paddle. Speed. There's no such thing as paddle speed. Like, where the heck did these things even come from? I don't know. Hard-coded the speed? Well, then I'll have to figure out where I'm missing that. Two plus number x plus 1. Obs size 2 plus num x. Okay. Yeah, so Noah, the way that we should do this, like when these variables get to be ridiculous like this, the way that you're going to see that we'll do it is we'll make a struct in C or Python that has all the data in it, like all of the stuff that has to get passed from Python. And then you'll have a NumPy return type, basically, that gives you a NumPy structured array. So you'll load the data into the NumPy structured array, and then that gets unpacked from C. And that prevents you from having to have all this intermediate garbage. And it also results in you having contiguous memory for state. So that's probably what we're going to end up doing. Now, I don't know. There are a few things I'm not positive on how to do with that. I think there's a little bit of pointer shenanigans, but we'll figure that out. Int equals 3. And I have the signature wrong here somehow. DT, frame skip, agents, width, height. This is backwards, so it's got to be ball width, ball height. Wait, ball width, ball height. Oh, my brain just did something weird. No, that's correct. Quick width, height, ob size. I don't know why it needs num bricks like this. Let's just do this. Undefined, okay. References. Handle. Paddle. Ball. 3. step dt. Function. Collisions discrete. That's weird. It doesn't like this is inlined. I don't know why that is, but that's fine for now. So, LD library path equals relib lib, and now I'm sure we're gonna have to debug a bunch of runtime stuff here. Where's the breakout? Break. Okay, so we get our first seg fault. 320. Paddle positions. This is supposed to be 2. Anything else? Well, not sure what's going on here. This is kind of a thing. Let's see if there's, do we have input on this yet? Yeah, we don't have input on this, so we need that. Yeah, but we need input. How do we do input here? I think we do like get is e down. Where is it? Oh, I think we do input in the demo file, right? The only thing that we do in the render is we do this, right? Snake or pong.h, C. Yeah, so you can see we do the input right here. This is how we do the input. That's a nice way of doing it. Oh, interesting. I actually already have it working here. End of actions 0. Okay, so it's not actually working then. Let's see why that is. Allocate balls. So these allocators need to be fixed first, because that'll give me some better errors. Observations done to reward scores. 3. Balls. Positions. States. Balls fired, ball, paddle width, paddle height. Tip counters. That's it. So now when I close this, those 3 memory leaks are system level. Raylib always has those. They're like below Raylib itself, apparently. They're like in OpenGL or something. I don't know. But we don't have any extra memory leaks. Since I see we have a lot of folks on YouTube now, just a quick little thing for new folks here. This breakout port is going to be on this website later today. It's ultra high performance breakout version for reinforcement learning, written by Noah, currently being ported by me, and it's all free and open source. It is on pufferai/PufferLib, which is right here. All this code is in the dev branch at the moment, and if you want to help me out for free, go ahead and star the repo. Helps me out a ton. Back to dev. Let's see how actions is getting used. So we allocate it here. It gets set here, right? Where does it get used? We get fire, left, and right. Those all look correct to me. So let's see, is it actually recording actions? Oops. Print. Okay, so you can see that when I press the buttons, things happen, but nothing happens on the screen. So apparently the paddle position doesn't get set. And the bricks don't get drawn either. Hold on. Nothing. Let me think about what could be wrong here. So this reset, I bet that this reset is not getting called correctly. Let's just get set. What if we set this to -1? I bet we're just not initializing correctly. We do reset the end. Let's see. Do we actually get prints here? You can see we do. We get all the prints for all the bricks, right? Oops. And then we do printf brick position. We can see that these are wrong. Why are these wrong? I called this right here, didn't I? Brick position. I assume something is just not getting set correctly here. One of these variables. Let's see which one it is. Brick width. Oh, wait, it's right here, right? Yeah, so this call needs to go after I initialize all the stuff. So now we see that we have correct positions here, or what look like correct positions. And we have the states. And we have actions. And it says if brick state is 1. Printf brick. We'll just use state. Ah, I think that this needs to be n. Brick colors. Okay, apparently there are too many rows. Brick rows is 6. And we don't have enough colors. Let's figure out what colors were used. Red, orange, yellow, sky blue, and blue. That's easy enough. 6 is going to be equal to red, orange, yellow, green, sky blue, blue. I don't know if you're still here, Noah, but I really liked your idea to make the PufferLib the ball. I think that's hilarious. So we're totally going to do that. Okay, this did not seem to help. These are still not being rendered. So we will simply F, brick I, state, okay, all the states are 0. So you can see it's drawing all these different bricks, right? But nothing is happening. Drawing brick at. I think we're just not setting these right. I thought that's pretty funny. Didn't get to be a good size where you see it's a puffer, while the ball is still hard to hit. Yeah, well, we'll just make the game render bigger, right? I really like that idea. That's awesome marketing, so thank you for the free marketing. I mean, it takes a lot to get, really specific tools like this out there. And fun stuff like that actually goes quite a long way. You know, you just have these environments, but the puffer fishes the ball. We should do it for Pong as well. Here's one row of bricks. I don't know why the rest of them aren't drawing. Let's figure that out. Probably because of the client. There you go. So not processing the actions for some reason. Let's figure out why that is the case. Step should be... Yeah, right here, right? Okay, so it's getting actions, but the sub-step thing. Okay, so it's moving units of 0 for some reason. 0.0. Oh, because this is an int. This is what? Very good. So now we have the paddle moves. Ooh, look at that. Wait, does it work? Nope. Nope. That was interesting. Let's play that again. So, oop. Yeah, something in the collisions. Very close now, though, to having it working. We'll probably put it online as soon as it works, and then we'll clean it up after, so people can play with it. The wall positions... Assumedly, wall positions doesn't get initialized. Yeah, you can totally see that this is, So wall positions has 6 numbers, apparently. 0, 0. How is this structured? Wall positions here? Hmm. Oh, left, top, right, I see. Yep, I gotcha. Actually, I only need to set one of these, right? It's end wall positions of 4. 1. Where's width, I suppose. I guess this is not allocated to be big enough, right? Okay. Here's your game. Well, this is definitely breakout. Yep, this is how breakout works, guys. It's actually hard to play because there's like no way to tell what the heck the ball is doing. I think it also goes through the paddle. Now this gets a little trickier because we got to figure out the brick collisions. Substeps. One. Where does this get set? Really want to see if someone can balance double pendulum. Let me see. Why is there so much stuff here for a simple project? That's a bizarre amount of files. What the fuck? This is very bizarrely written code.